Hello, everyone. Thank you so much for being here. My name is Mariah, and I will be talking about testing the SeQueL. Just to give you a little overview about me, I'm a staff analytics engineer at a company called Perch Energy, formerly Arcadia. And yeah, I think about testing a lot, so hopefully this resonates with a lot of you. Just to go quickly through an agenda for the next 30 minutes, we're going to start by throwing it back to 2022 and see how far we've come in the last couple of years. Then we will go through some of the newer challenges that, at least from my perspective, it seems like we're facing as a community in the data quality space. And then I'll tell you all about a new design pattern that I think is cool and that we should totally steal from software engineering. And then we'll look at an example use case and how it can hopefully improve data quality and maybe even business relationships. Then we'll recap, see how it's gone, and see where we're at. Okay. So throwing it back to 2022, if you couldn't tell based off of the title of this talk, this is actually a SeQueL. I gave a talk in 2022 in New Orleans at Coalesce about testing, and this is a direct follow-on to many of those topics and themes that I covered in that talk. So if you haven't seen the 2022 talk, it's totally okay. It's not a direct prerequisite, but I will leave it as an exercise for you to go back and watch later, because there are a lot of themes that I'm not going to be able to go into as much depth this time, that you'll really get a lot out of what you hear here when you have more context about what I talked about there. All right. So in 2022, at least from where I stood as a practitioner, I believe that as a community, we're collectively over-focused on testing data. We also didn't, at the time, have true distinction between testing our code versus testing data. And the tooling options were a lot more limited than we have now, a lot more new tools coming out that weren't broadly adopted, and of course, there was no AI in any of them yet. So my overall thesis in 2022, and the recommendation that I made, is that we should first and foremost be testing assertions, which is transformation logic and code itself, not testing data, and observing data and its conformity to our expectations. And we should not, under any circumstance, be conflating these two practices. And then lastly, I made the call that as a community, we all need to do better to work together in driving forward what it means to do testing well, to have good testing hygiene, best practices, and what it means to have a robust data quality strategy generally. And now we're in a much different world, as I'm sure we're all aware. There's a ton of new tooling solutions out there that can enable us to do testing well. We've got dedicated unit testing in dbt itself, so we can be sure of our code's integrity before we deploy it onto real-world data. We have, of course, the regular singular and generic dbt tests. We've got lots of packages with tons of more advanced testing options for the data testing part of the process. We've got machine learning and statistical anomaly detection frameworks. We've got observability. We have greater advancements and also socialization of patterns and practices around improved CI/CD, things such as blue-green deploys, write audit publish frameworks, as well as integration testing and what that means to do integration testing on a dbt project. And then, of course, there's AI and all the crazy stuff that it's enabled in the past year or two. And beyond tooling, I am happy to report we also have had advancements in the best practices front. So new standards of practice have begun to emerge, driven in large part by things like the dbt developer blog and co-authored posts that have been ushered by dbt labs themselves as spokespeople, as well as community members. Specific community members have created amazing resources that are out there available for anyone to use and reference. Things like dataqualityguides.com, which is released by the folks over at Sync. And this is an amazing resource. If you haven't seen it, it's got tons of really palatable small chunks of actionable things that you can do to improve your data quality and testing strategies. And then, of course, other forms of media provide a lot of content in this area, like podcasts, other blogs, articles, you name it. And then, of course, the analytics development lifecycle, the white paper written by our one and only Tristan Handy, DBT Labs. And honing in on that for a second, this white paper has, sorry, lost my place. So this framework provides a lot of non-prescriptive recommendations about improving your analytics workflow as a whole, from writing code, testing code, deploying code, all the way to the human side. Collaboration, governance, data operations, and everything in between. And in the white papers, there's this one quote about data quality and testing specifically that really resonated with me, which is, oh, sorry, forgot my transitions got a little messed up, bear with me. Okay. It's kind of long, sorry, but from increment.com, once you deploy, you aren't testing code anymore, you're testing systems, complex systems made up of users, code, environment, infrastructure, and a point in time. These systems perpetually and eternally defy your ability to deterministically test. Said another way, most of the bugs you find are not errors, they are a mismatch between your business logic and the real world. And you can never fully anticipate the real world in your test environment, so you inevitably need to test in prod. And I thought this was really interesting. And this brings us to something that, at least from my perspective, is kind of a new frontier in our data quality journey, which is the edge cases. And I have another quote from that same article that Tristan quoted on the previous slide, admitting that some bugs will make it to production no matter what we do has been an unspeakable reality. And this is the reality of a data practitioner. Edge cases are going to find their way in. We can have all the bells and whistles in the world, we can have the most advanced testing strategy, and the bad data will still get in. I almost guarantee it. And when these bugs sneak through, you might find yourself in one of two equally bad situations. The first is that the bad data makes its way into your production model outputs and it breaks something. In this path, you might find yourself with alerts to triage constantly, pipelines blocked, production tables going stale, and maybe you even have your service level agreements at risk because your pipeline is not updating. Then on the plus side, at least, the bad data that broke the pipeline didn't get in and contaminate things. But then on the flip side, the other path that you might find yourself down is exactly that, contamination. If you've got unanticipated edge cases that make it through logic undetected, or maybe you just let them pass through with a warning and not a circuit-breaking test failure, then you end up with potentially unexpected behavior, incorrect calculations in your metrics, buggy logic, transformation code performing in unexpected ways, and ultimately this leads in a decrease in trust overall of you as a practitioner and the things that you produce, but also your pipelines and the reports that you generate. But hey, you might still be meeting your SLAs. So these situations are both equally bad. I hate them. I want to avoid this as much as possible. And I think that sometimes as practitioners, we take for granted project uptime. Some use cases, especially in my business, just don't have the luxury of taking down production. We've got critical SLAs and oftentimes even contractual obligations to our clients to deliver reporting on a certain cadence at a certain quality, and we can't interrupt those cycles. So how do we acknowledge and handle bad data without blocking our pipelines nor contaminating those sources of truth? Well, I think that we should take our bad data and push it somewhere else. No, really. So this talk is called the SeQueL, besides the fact that it's the second talk about data quality that I'm giving. It's actually not even about testing. Surprise. It's about the SeQueL functionality that's available to us and what we can do with it, namely our where filters. So filters can do a lot more for us than I think we give them credit for and that we might be using them for now. And this brings us to a new SeQueL pattern. Maybe not 100% new. I actually don't know if anyone else is doing this or not, but it was new to me when my manager kind of came up with the idea last year. And we call it the quarantine pattern. So what is a quarantine, first and foremost? It is an existing pattern in the world of software engineering, namely in security and cybersecurity, information, networking, where it's a pattern of isolating potentially risky files or software from interacting with the real world or the production environment until they have been marked trusted, typically in a manual review process, but sometimes there's automations that can help with this. And you might be familiar with them if you are on a corporate email server that has filters for phishing scams. You might be familiar with the second inbox-like environment where you can't click any URLs, you can't open any files. All you can do is review the email and then say, I trust this sender or not. And when you do, then it frees it up. You've marked it trusted. And apologies for the weird transition again. I see the need for a parallel structure in the data world, especially where we apply our transformation logic. We need a way, click. We need a way to prevent our bad or unexpected data from making its way into our governed production model outputs until it's gone through a review process and is marked as trusted or otherwise whitelisted. So how can we do that? Well, my proposal, and bear with me for a second because I feel like this might get some strong gut reactions, is what if instead of one model, we have two? One for the good and one for the bad. So our good model will be clean and trusted. And we can define strict rules that govern exactly what data shows up in the outputs. And the result is that nothing ever ends up there that we don't fully expect to see. And then our bad model is our quarantine. And in this model, we have much broader inclusion rules that are following the logical inverse of whatever those strict rules were in our good model that captures everything else. And then it also will present these bad records in a clean table, just like our reporting ready table, to allow us to surface those things up to our data producers or handle them and review them and learn about our edge cases for handling later. So this is a slide from my original talk with an example of testing assumptions versus assertions. And what I basically said is that on the right is what we want to aim for, where we have code that defines some constraints, and then the test case that we apply validates that constraint, rather than validating underlying data values, which is a bad pattern in my opinion. But OK, so then we're going to take the same example and go one step further. We take that same transformation logic, and then we apply a strict rule on the outputs. And this model should thus only have rows where the status is exactly what we expect to see, shipped or placed, nothing else. Then we do the inverse for the quarantine. And obviously, there's some duplication of code here in this example where, of course, there's opportunity to dry it up, use an ephemeral model or an intermediate layer so you don't duplicate the transformation logic itself. But this is basically what we're aiming for. So now we're covering all the cases where status is not shipped or placed, including statuses of nothing at all. And when we're implementing these filters, I would recommend that we don't just go loosey-goosey, OK? We want to be intentional. We want to think to our strategy objectives for testing. So we might be developing our models with some certain test cases in mind that we want to validate, like not null columns, uniqueness constraints, et cetera. And now we're going to take those tests and instead apply them as filters. And so this means filters on pretty much any transformed column. Click, click, OK. You've got your DBT generic tests, things like not null, accepted values, like the previous example, et cetera. And instead, we apply these as where filters. You can also do things like pattern-based inclusion rules. Or you might have specific distributions or aggregations that you want to like sanity check your metric value calculations. Basically anything, sorry, anything that you can test from pretty much any package with advanced testing or embedded DBT packages, embedded DBT tests, you can convert into a filter, as well as things like uniqueness constraints on your table grain assertions. You can use qualify for that, or if you don't have qualify, there are ways. Come see me if you need help. So yeah, that's what we do. And then, of course, we do the inverse of that when we're applying the quarantine logic, or logical inverse. And this is not going to be a replacement for testing by any means. And as I've said to literally anyone who has ever talked to me about the topic of testing, we want to test our assertions. And we just added a whole bunch of new assertions into our model logic, OK? Then we want to be intentional about where we apply quarantine. We don't want to suddenly double our DAG and have 2 models everywhere that we used to have 1. That would just be silly. So we want to have intentional checkpoints in our DAG. And in my opinion, some of the best places for that would be on deliverables, like a report that's going to see the light of day, or a data product that's governed with the contract, or highly leveraged models, like central nodes that feed a lot of downstream use cases. And so I'm bringing this quote back from that original quote that I posted earlier from Tristan in the ADLC white paper, to emphasize that we can never fully anticipate all the potential edge cases that we may eventually see come through our data in the testing environment. So we will inevitably need to test in prod. And my argument here is that I think the quarantine pattern gives us a clean way to both test and observe data in production, but potentially without the downtime that is implied when you say testing in prod. So some of the benefits of a quarantine structure include the fact that your bugs and unexpected data points become a lot more visible in a proactive way. So you've got this ready table that you can query just as easily as any other model that can show you exactly what the misalignments are in the data points that you got compared to what you expected to see. And as things are improved upstream, as you handle those bugs or add new cases to your model logic, the quarantine itself will shrink as those new records flow through the happy path the next time around, and it will grow when new issues start to pop up. And that fact in itself creates a dynamic and automatic backlog of issues for you and your team to handle as time and bandwidth allows. And this is my favorite part, that we're no longer beholden to failure alerts, having to go drop everything to get pipelines back up when something breaks. And we can plan for dedicated time and bandwidth to tend to that issues list when we have the flexibility to do so, and we can prioritize at will or escalate certain types of issues as needed. And not only that, but we can use the quarantine to report on our own success. So we can generate metrics like tracking number of issues identified versus fixed, the volume, the speed to resolution. We can also identify and report on responsibility over the production of certain types of data quality issues, whether it originates in the model logic versus upstream data production. And then besides a health signal, we can also use it to leverage for prioritization. So we can use the quarantine to alert on some of these health indicators. We can also profile the quarantine data itself to identify patterns and say, like, we get a lot of a certain kind of issue, a category of issue, and we can see that it could provide a potentially large impact. If we fix it, then we can leverage that as evidence to provide a case for prioritization. OK, so let's go through an example situation to get a better idea of the type of impact a quarantine might have on a real business problem. So let's imagine that we are a company that does client services. We've got corporate clients, and we have customers, like individual people. And those customers are also customers of our clients. So we're kind of like a middleman situation. And we get data from both sides. So we get data from a file ingest process from our clients. And we also get manually inputted data from those customers through an internal platform of some kind. And the objective here is to perfectly connect the records from both systems and match them to the right person, with a catch. There's no guarantees of a primary key identifier. So instead, we have a handful of properties from both sides of our data that we know about a person. And those things might be their name, their date of birth, maybe a method of contact information, and maybe, if we're lucky, something like a third-party identifier, like their taxpayer ID or a membership number. So the objective is to match both data sources to the same individual and then ultimately produce a new report that takes part of the full picture from each side and combine it into the full picture to then surface back to both customers as a report. So the important thing to note is that any match that's not successful here, we're going to have some very unhappy people. And there are maybe real-world consequences to getting it wrong. Assume that we have really sensitive data, things like medical history, which is protected by HIPAA, and there's absolutely no tolerance for false positive matches. So what do? Well, as analytics engineers are apt to do, we develop a matching heuristic, something that matches on as many of those attributes as possible, and then we score with a certain level of confidence, and only above a certain threshold of confidence do we actually present that as a successful match. But we might run into some roadblocks. What if the customer made a mistake in their manual inputs? Maybe they mistyped their own email address by one character and didn't notice. Maybe they have a nickname that doesn't match the legal name on file with the client. Or what if the client sends us a batch of data that's missing one or some of those attributes that we require in order to make the successful match? Suddenly, we can't make a perfect match, and then we can't deliver reporting on those customers. So let's say we make a quarantine model on the output of our matching heuristic, and anything that matches with a certain high % of confidence will move on down the modeling pipeline to our reporting layer, and the rest will end up in the quarantine. So we're going to now generate some reports on that quarantine. But this time, we're going to target specific action that we're going to ask of our customers. So we're going to say, hey, we got this data from you, but we couldn't match it to our records. Did you mean this? And use one of those slightly lower confidence potential matches, just the properties, not the whole record, because that's still PII sharing, and say, this might be what you meant. Can you confirm or deny? And depending on what they say, we're still going to action on whatever they say. So if they say, yes, I misspelled it, let me go fix it, great. It'll go through the happy path next time around. If they were right the first time, then we now know, OK, the difference is in our comparison data set. So we have some leverage to go back to the other producer of data, our client, and say, you said that you have customer X, but we have customer Y. Can you please fix this? And if you can't, I cannot deliver the reporting that you want until you do. So they have some incentive to get that fixed for us. Oops. OK, so everybody, this is Drew. Drew is actually my mentee in the Data Angels mentorship program. And in one of our sessions over the past few months, I told her about this idea that I was having about the quarantine pattern and that I submitted it for a talk at Coalesce. And she ran with it in her own work, to my surprise. She had just started a new job, and she was faced with that exact business problem that we were just talking about. And I probably told her about this pattern for a total of 5 minutes. And she implemented it, and by the next month when we met again, she already had a bunch of evidence to give me for this talk. So let's talk about how it went for her. So first and foremost, the quarantine helped Drew to reveal some of those critical, unexpected use cases that she could never have anticipated when she was developing her heuristic logic. But since she had a strict condition on what would pass through the happy path, nothing got contaminated. No false positive matches were made. Everything retained a high level of confidence, and the clients were happy with what they got. It also helped her to build a business case for improving particular classifications of issue, also known as leverage. So she was able to quantify the size and level of impact of certain categories of issues, and then use that to estimate the level of effort it would take to fix them, and bring that as evidence back to her higher up management to say, if we fix this problem, we're going to see a huge increase in success here. And lastly, one that she mentioned in passing, but really stood out to me, is the fact that the quarantine allowed her to move forward even when the results were not perfect. And this is something that I think affects all of us in specific types of modeling. When you just can't get the edge cases right, you spend hours toiling away at perfection, when really this isn't a great use of your time. Your customers are sitting around waiting for you to deliver a data product to them, and you're not delivering. So in reality, we should take this approach, in my opinion, where we get it to 80%, we release it, we make sure that it meets their needs, and then we've got this quarantine evidence that we can go back into our next iteration cycle and say, hey, I already know how to make this better for you. Let's keep working on it. But you can still move on without perfection. And this, in my opinion, is better than the situation we were in before, where maybe we've got some test cases that are perpetually failing and alerting us over and over, alert fatigue, you set them to warn, and then they just slide. Now you've got an alternative that's a little bit more actionable. And this is a quote from Drew that I really liked. I tried my best to capture the exact quote. Deal with them later. OK, so Drew also had some ideas for future ways to further leverage the quarantine in her own work. So one idea is to have a UI that surfaces those quarantined records directly to customer service agents so that they can action on them right away. And they're going to go talk to the customers, and they can get that data fixed. Another idea is to implement quarantines on more parts of the pipeline so that you can really hone in on where certain types of issues originate. She also wants to do what we've already talked about, monitoring the quarantine to see how data quality issues change over time. And she wants to leverage the quarantine evidence a lot more with her relationships with their clients so they can try to influence better data production hygiene. So, did we do it? Did we solve data quality? No, of course not. And I would argue that this is not a magical solution, although I did really try to make it seem like it. I will be the first to admit that it's not the easiest thing to implement. It is a medium level of effort to get a quarantine set up on a set of models and actually make it effective. It's also kind of a prerequisite that you have a pretty mature data quality strategy already to draw from, because you can't just start from 0 and get to quarantine without a solid baseline, in my opinion. It also means a lot of different, skipped ahead. You must actually use the quarantine in order to get the benefit. If you just let the records go in there and then you never look at it, you never try to fix it, you've lost any and all benefit. It's also not applicable to every single use case, and I've mostly focused on customer-facing data product development here, but it might mean very different things to use it on an internal analytics use case. I personally haven't explored that very much, but I would like to do so. And bringing it back around, see slide 12, admitting that some bugs will make it to prod no matter what we do. Yeah, that still applies. So the goal here is mitigation, harm reduction, if you will. And we want to make our systems as resilient to errors as possible while being strategic with our priorities and being protective of our precious time. And I do really think that quarantines can help us start to get there. So I hope that you'll try them out. And I'll leave you with these 2 quotes. I won't read them out loud this time, but this is my new favorite article ever, the one that Tristan quoted, the one that I've quoted repeatedly. It's called I Test and Prod. And it's not at all about the data domain, by the way. It's about software. But everything in there is super salient to things that I deal with, and I think everyone can benefit from reading it. So yeah, that's it. I would like to thank Drew especially for being the guinea pig here and giving it a try, proving that it can work. Also like to thank my former manager, Dan, for being the person I credit with this idea and being some of the motivation behind this talk. And then my current manager, who is only my manager for the rest of the day, sad tear, for being a rubber duck in my process and really helping me through developing this talk. And yeah, that's it. You can find me on Blue Sky, LinkedIn, or Slack, Data Angel Slack, or DBT Slack. And yeah, thanks everyone for attending. Hope you got a lot out.